Okay, ambassadors, you need to have a look at this first sheet here, which says K4a. Okay, this is your activity sheet, and it will give you extra help in understanding what you need to do. I'm going to explain it for you, so listen carefully and take notes. Here's your equipment. You have the power supply, you have the ray box and the slit, and what you need to have also is some mirrors, protractor, and under here is some graph paper. For the investigation, first thing you need to do is set up your equipment properly. We're going to use this output here. It's AC for alternating current. It means the current goes in different directions around the circuit. You plug that in here like that, and you check that it's adjusted to 12 volts. Okay, 12 volts being produced. The push of the current around the circuit and through the board. Also need to make sure that your power supply is switched on like that, and you should see your ray box starts working then. And you want it this way round. Okay, see there's two ends of the ray box. You want it this way round, and you want to use a single slit. Put the single slit in the front like that, and you get a nice collimated beam like that. And you want to direct that at your mirror, and you see that the light bounces off. Okay, we're going to be investigating this reflection, okay, that's going on here. First thing you need to do to start your investigation is to get your graph paper. Okay, you can see the graph paper has, maybe you can see it has squares on it, so it's going to help you out a lot here. And the first thing you do is mark on where you're going to be putting your mirror on the graph paper. Okay, so line it up with the squares on the paper and draw a line parallel to the mirror like that, and just put a little line on either end so you can see exactly where the mirror goes. Okay, like that. So that's where we're going to be putting our mirror. Then the way you label a mirror is with these little dotted lines like this. Okay, so that means mirror. Okay, white mirror on it as well. Okay, so that's the first thing you do. Label on your mirror. Second thing you do is you want to mark on your normal line. Okay, I'm going to do that in a different colour pen just to make it clear. I'm going to use a ruler. You shouldn't be using pens, you should be using pencils. I'm only using pens just so it can make it easier to see. Now the normal line is a line which is perpendicular to the mirror, and I'm going to draw it with a dotted line like so. Okay, so it's at 90 degrees. If you get your protractor out, have a look at the protractor here. An angle of 90 degrees, you can see the numbers start off here at 0, and they go around clockwise to 90 degrees there. So that angle in there is 90 degrees. And look on here, the angle between my normal line and my mirror, if I measure it like this, is 90 degrees. Look at the green line, look at the red line. So going clockwise around here, that's 90 degrees. Okay? You represent an angle of 90 degrees on a diagram by drawing a square like that. So you can do that as well. Right, next thing you need to do. So that's the second thing you do, is drawing the normal line. Third thing you do is excuse me, choose how your ray is going to hit the mirror. Okay, so I'm going to replace the mirror like this. Okay, we're going to direct the incident ray, which is this ray here, so that it hits the mirror where we've drawn the normal line coming out. The normal line is coming out just here. Okay, so do that, and just so that you know that the angle that the incident ray goes in at, we can actually draw another line showing the incident ray going in, and actually we should choose to do it at about 40 degrees. So I get my protractor out and I want to mark on 40 degrees measured from the normal line round. So 40 degrees that's about 10, 20, 30, 40 degrees there. And so this angle in here is 40 degrees, 10, 20, 30, 40 degrees. Okay, I'm drawing any blue. Here's my ruler. 40 degrees, like that. Okay, so that angle in there is 40 degrees. Okay, you might need some help trying to use the protractor, but that's 40 degrees. So replace my mirror on there like that. Direct my incident ray 40 degrees in like that. And now comes the interesting part. You need to measure the angle of reflection, which is the angle of incidence, represented by letter I. We need to measure this angle in here, which is the angle of reflection. So I'll use a blue pen again. I'm going to draw on the angle that my reflected ray is coming out at, like this. Okay. And if I take the mirror away, I can make sure it goes all the way to the all the way to the mirror, like that. Okay. There you go. So I've drawn the reflected ray coming out here. Now I need to measure that angle in there. So this angle measured between the normal line and the reflected ray is what you need to measure next. Okay. Once you've measured the angle of incidence, the angle of reflection, you plot them on a graph and try and find out a relationship between the angle of incidence and the angle of reflection.